Good morning, all. Can I have your attention, please? Welcome to the Faculty of Medicine, Future of Medicine morning. I'm Dr. Brent Norton, class of '84. Shameless little promote. I'm a venture partner at Lumira Ventures. That's the former MDS Capital, for those of you who ever were involved with MDS Capital. Lumira is Canada's largest venture capital firm. Our most recent fund, Fund 3, we manage money for 12 of our major Canadian pension funds and 12 family offices, invest solely in healthcare, particularly therapeutics, devices, and digital, and based in Toronto, Montreal, Boston, and Vancouver. My wife, Julie, is with me. She's just over on the right. Julie has a unique claim in the world in that she is the daughter of 2 McGill graduates, the wife of 1, and the mother of 3 students at McGill right now. And I just wanted to open with a little bit of an anecdote around the journey, my journey that brought me here, to set the stage for this morning. So a few years into my postgraduate training here, I decided after doing the research in biomaterials and engineering, that I really wanted to refocus my career around driving medical innovation. And then went and talked to the then Dean, Dr. Richard Cruz, thinking I would be thrown out of the department, the faculty immediately for thinking of going and doing an MBA. And to my surprise, and I guess I shouldn't have been surprised because he was quite a visionary, he endorsed the idea. But as a sort of sign of readiness for where medicine was going, I felt most of my classmates, both here at McGill and then at Ivey Business School, were none too happy with me. And it was some were even angry. I was actually commented to my face that, what are you doing here? You don't need this degree. You know, you're taking someone else's spot. And it was a tough time. 15 years later, so the point being is there was really a hesitation around thinking about innovation in medicine. About 15 years later, Dr. Dennis Sprecher of the Cleveland Clinic gave a keynote podium at the American Heart Association annual meeting. And his keynote was on non-invasive diagnostics. And it was such a powerful keynote that USA Today covered the story, gave it a third of the front page of USA Today, where they talked about Sprecher and me and some of the things that were going on in healthcare in terms of the future. And we were really proud that this was the direction things were going. But what surprised us was Jay Leno that night opened his monologue holding hamburger and fries with everything dripping down his hands. And Jay Leno made this joke when he put them down. He said, "Now test me now. You know, I've got you fooled." And so it was another sign that we weren't ready for where medicine was going. This morning, I think you'll find very interesting, and I'll set the stage with a couple comments. Recently, Vinod Khosla, famed Silicon investor in healthcare, particularly AI and digital, gave a talk called 20% Doctor Included, The Evolution from the Practice of Medicine to the Science of Medicine. And in that talk, he had 2 particularly amazing quotes. And I share them with you just to really set the stage for Dr. Edelman and Dr. Williams. A data science will do more for medicine than all of the biologic sciences combined. Heresy to say that in this room. Absolute. And then he went on to say that the increasing utility of 24/7 network medicine with bionic assistance, where 80% of the diagnosis, prescriptions, and monitoring doctors do today will be replaced by machines. 80% of the work we do today will be replaced by machines. And this is what he is investing hundreds of millions of dollars in right now and what's going on in the Valley. It is my view that the future of medicine is now. This topic could not be more relevant, and I really hope you enjoy this morning. This morning was put together by a really committed committee with Dr. Edelman, Dr. Sam Benaroya, Dr. David Dannenbaum, Manly Key, many of you saw Manly coming in, Sarah Odell, and Mukhtar Abdi. We just want to welcome Dr. Edelman, who's here, our Dean and VP of Health Affairs. And today we're going to hear from 5 of our alumni, Dr. Dave Williams, Dr. Iris Gorfinkel, Esther Sternberg, and Dr. Michael Viola, and my own classmate, Dr. Joel Wolkowicz. A couple of key issues we all need to pay attention because the group went to great lengths to get this CME accredited. So a couple of things. You need to thank them for doing that because this really counts for us. All speakers, you have to lay out your disclosures as part of the rules. Participants, you have to remember to, I hope you all signed in, and remember to do your forms and sign out with them. They are part of the package we have to submit. And then lastly, we're going to have Q&A throughout the morning. It is recorded for others to watch online who couldn't be here. So I'd like to call on Dr. Edelman to come up. Dr. Edelman has been the Dean of the Faculty since 2012. He's also Vice Principal, Health Affairs at the university. He received his MD-CM degree in 1979 and is currently celebrating his 40th. Yep. And making the time for us here. After completing his residency in internal medicine in Toronto, sorry to use that word, he returned here to train in respiratory medicine and practice in the hospitals at the MUHC. And before becoming Dean and Vice President, he was Chair of the McGill Department of Medicine and Physician-Chief at MUHC. Dr. Edelman is a Fellow of the Canadian Academy of Health Sciences. He is also an accomplished clinician scientist whose research focuses on inflammatory disorders of the airways.
Thank you very much.
Please welcome.
Thank you, Brent. Okay, good morning. Well, good morning, everybody. Welcome to the CME Symposium. So for a couple of things. So first of all, for those, I'm sure this is one room that every medical student has spent time in, which is now, it was M1 when I was a student, but it's now the C.P. Leblanc amphitheater. So those of you who remember C.P. Leblanc, who had him for anatomy, I know that there are many sitting here. I used to sit just about there with my colored pencils, where Yves Clermont and C.P. Leblanc would draw these masterpieces of chalk art on the wall, and we would copy them down. So it's always great to come back to this room to have a seminar. I want to reiterate the thanks for those who put together, who reviewed the symposium with me, Sam Benaroya and David Dannenbaum, and those who organized the symposium. I feel compelled to say that it is normally the responsibility of the 25th year class to organize and present this symposium. For reasons that are best left unsaid, they declined to do so and are not actually present as far as I know. And so we, rather than canceling the symposium, decided to look through the people who are coming back and pick really a superb group of creme de la creme presentations that you're about to enjoy. And I think that we're going to have one of the best CME symposiums that we've ever had on a Saturday morning here for these talks. I hope that everybody has been taking advantage of homecoming and having a great time at their reunion events, and those, we still have our 40th dinner tonight, but and I hope that you're learning more about what we're doing here in the Faculty of Medicine to really start ourselves off on our 3rd century of excellence with our commitment to building healthier societies through research, education, and clinical engagement, community engagement. So without any further ado, I want to thank all the speakers. I want to thank you all for being here, and I wish us all a great symposium. Thank you very much.
Our next speaker, Dr. Iris Gorfinkel. I had the pleasure of meeting her at a McGill event and built a relationship there for the first time, and was reminded of that this morning of our extended McGill family. Dr. Gorfinkel is from the class of '89, a youngster. Oh no. A family physician, professor, and patient advocate. She currently operates her practice in that other city, is the founder and principal investigator at Prime Health Clinical Research, and also serves as an external peer reviewer for the CMAJ. She's passionate about patient empowerment through facilitating knowledge sharing. Iris will speak to us about patient portals of access to electronic medical records in family practice. Welcome, Iris.
So thank you so much, Brent, for that beautiful introduction. Maximizing the power of patient portals. So moving into the next phase. I actually really like this cartoon. It's so low tech, but it's kind of cute. The frozen implants with the chicken. Yeah, it keeps us humble. So who am I? I guess I have to give you the disclosure because this actually does form a good part of the talk you're hearing, but it's all background stuff. So I'm a principal investigator and founder of Prime Health Clinical Research. Don't be so impressed. I've just done a lot of clinical research in a private office, and I've been paid by pharmaceutical companies that you see before you. It's a long list because it's over many, many years, and that does inform, to a great extent, the way I practice medicine. So I've received speaking fees from GSK. I've co-chaired the board of a large trial we've done and continue to work on is the Shingrix vaccination trial. So I co-chair the advisory board on that. So the learning objectives for today. I want to review the current barriers, of which there are many, to access primary care records and understand the rationale of why that's so important to have access to our charts and redefining the future EMR and primary care as a collaboration as opposed to something that's used by doctors for doctors. So if we consider now, what are the barriers to getting care? So I want you to consider this talk from two perspectives. The talk that yes, you're a doctor, from the rather selfish perspective that these notes belong to us and they're written for us and by us and to share with other clinicians. But I now want you to ask you to put on a somewhat different hat, the hat that Dr. Dave had to put on when he turned 50. It comes on at the drop of a dime. You see your doctor and you're given a hard diagnosis. That's the other hat I want you to wear. So you've got two ears, and we're going to listen from both perspectives. The perspective of the doctor and the perspective of the patient. So if you want your information now, you face a number of barriers to get that information. Not the least of which is signing an authorization form that then goes to your primary care doctor, if you're lucky to have one, and being a family physician, actually we're far less, a physician of any kind is actually much less likely to have a working family doctor, somebody who's really looking over all of your care. But if you're lucky to have one, then once you've signed that authorization, it goes to your family doctor, who then looks at it, who then considers it. It probably goes into a pile, and there is a delay in your getting access to your family practice records. And this is a huge problem. You may be then charged a fee for getting your records. And that's like actually standard throughout Canada, and that fee can range anywhere from $10 to as high as $225 if your records happen to lie and wait in a facility. So it can be very costly. And then you have to suffer the delay in getting those records. So by the time it's photocopied and sent to you and you receive it, you could be looking at a month, 2 months. I've seen patients where we've requested it 2 or 3 times and still haven't received it. So this is a big barrier for you. That's a problem. And as a family doctor who's trying to do my best to help you now, if I'm your new family doctor, that's a major issue. If you're a hospital trying to assess a patient, it becomes not just an inconvenience, it becomes a potentially life-threatening situation. You can't remember the name of the medication you were given 10 years ago, but you do remember that there was a serious problem with it, and now you could be given that medication again. You know you have a medical problem, but you're not sure what that medical problem was. We live in a siloed health system. You've heard that term before, and I hate to flog a very dead horse, siloed health system. But I'm going to do just that, because when you don't have your family practice records when you need them, you've got a major problem on your hand. And this is kind of from outer space, whoosh, right down to this really tiny little speck on a speck problem. because all of a sudden that does become your world. So what can we do about that? The concept of patients accessing their own chart goes back to, and this is going to shock you, an article was written in the New England Journal of Medicine as early as 1973. You have to hand it to Dr. Bud Schenken, who said that giving every patient his primary care record, that's what it was actually entitled, that was the style of writing at the time, would increase quality of care, increase the relationship with their doctor, improve continuity of care, and avoid unnecessary bureaucracy. Now, I would ask you, at least conceptually, would you agree with that? Do you think that makes sense? That having access to your primary care records would do all of that? Turn the clock forward to now. So if you look at North America wide, 40 million people actually do have access to their records thanks to a system called Open Notes. That's largely available in the United States. In Canada, we unfortunately don't have access to our primary care records. There are spotted areas in which we do, but largely we still need to work much more toward that goal. To some extent, I've heard it argued that really, who are the records for and who do they belong to? Well, frankly, yesteryear's records were made for physicians, by physicians, with the idea that perhaps, auditors could read them, lawyers could read them, but patients were not really a part of that picture. So with that being the case, the charting was very, very different, right? We would use whatever abbreviations we wanted. There were simplifications that were utilized. And how we charted was really different. With this concept, it is not a unidirectional concept, but rather a bidirectional concept. So all of a sudden, everything changes. And that's what I want to do. I want to challenge your paradigm of what medical record keeping generally is. It is not meant for us. Ultimately, the only reason we write a record on a patient is for the patient, so that that patient can then be empowered to do what they need to do for their own care. So what if we learned from the Open Notes experience in the United States? Well, they just published a full article on what came out of it. And what was learned was this, was that in fact, patients were impressed with the quality of care they received. They said they feel far more empowered to act in their care. And in fact, they were able to demonstrate that patients were not just a little more adherent to care, they were far more adherent to recommendations. So other research that has looked at, what does the doctor think? How did you do in that visit? Do you think the patient's going to pay attention to what you say? And doctors, just like in other realms, we tend to overestimate our abilities. It's a cognitive bias that we have. We believe that we're good at what we do. No one is average. We're far better than average. And we also believe that patients totally trust in us. We're really good. And what happens is that we're actually shocked to learn that patients don't buy into it. They don't buy into it. They don't understand it. They can't afford it. There's a whole bunch of stuff going through their head. And we are just, again, a speck on a speck. But when patients have access to their clinical records, they are then empowered to change their perspective. They see themselves outside themselves, and it allows for a better adherence and therefore lowers downstream costs. So there's a lot of metrics that argue very favorably for giving patients their charts. And I mean everything. I don't mean just their labs. I don't mean just their medication lists and their allergies. I'm talking about everything. I'm talking about the clinical notes as well. So doctors say, oh, I'm so worried. They're going to come back to me. They're going to be anxious. Actually, that's not borne out by the studies that have been done on this. It actually lowers workload overall. Another common fear is patients will look at it and will be very aggressively angry at us for getting it wrong. So I get tons of notes from specialists, of course. I'm a GP, that's what I do. I look at it. And it's And I find it absolutely fascinating. I don't know how many of you are GPs or family doctors, but sometimes when you go over the notes of the specialists with the patients, they are shocked. They can't believe it. They can't believe that this is even them in the room. They're like, but that didn't happen. Or I told him it's not that, it's this. And you know what? I really am afraid of that too. Can you imagine that me as a GP, I open my records? You know how many things they're going to find wrong? Tons of stuff. I didn't get it wrong just some of the time. I probably got it wrong at least a little bit on almost every patient encounter. That's actually an evidence-based statement. Even when we use checklists that try to keep us in line, we get things wrong enough of the time. And I believe that when patients come back to correct us, that that's actually a form of patient engagement. It should be redefined, not as error, not as shame, and not as guilt, and not as bad, Dr. Iris, bad, you could have done better. It should be redefined as patient engagement. And the patients should be congratulated on reading through their charts and now becoming an active part of their own care. So this model is not a unidirectional model. It's a bidirectional model. It's a chart for the patient, and the patient reads the chart and ideally has a private mode of speaking to the doctor and saying, this is what we could be doing better. So there's lots of arguments to be made against this perspective, not the least of which is security. How can patients possibly afford this or have the knowledge around it? There's physical barriers, emotional barriers, technological barriers, security barriers, it just goes on and on. But I think ideas start from just that. It's a concept. I don't have all the technological answers and how we're going to make it secure, but I think over time that'll become clearer. But what I do know, heart and soul, is that patients need access to their care, to their records, to be empowered, to improve their adherence to recommendations, and that also goes for psychological records. So how scary is that? Looking at one's own psychological self. I'm going to come back to what I mentioned, the first thing in the talk, which is what allows us to heal. What allows us to heal is to take the problem away from ourselves, to talk about it as a thing which is separate from our whole being, and then act on that. And this is that. So if I suffer depression and I see my doctor's notes on my depression, I then see it from my doctor's perspective. And what does that allow me to do? That allows me to step away from myself and see it away from myself as a separate problem from me, so that I can then be empowered to act on it. And it's interesting, that's exactly what the research is showing. So two little snippets of research. So Sunnybrook, my chart, they looked at what are the aspects of the clinical record that patients are actually focusing on. Are they focusing on labs? Are they focusing on x-rays? Are they focusing on clinicians' notes? And not surprisingly, most of the clicks happen, and the biggest viewing times are on the clinician's notes. After all, what could be more interesting than me, to me, and reading about it from somebody whom I respect? That perspective. And the answer is, that's what they focus on. Your clinical notes matter, and they matter a lot. Much more than your copy and paste, much more than your digital checklists. What people look at the most are your verbal notes, like what are you saying about them? And that is a huge and important platform. It allows for tremendous change, and I believe it's largely untapped. If we were to take this to just a little bit further, so what else could we do with this? Now you're entering into the theoretical space of my extremely small cranium of the speck on the speck, which is like dangerous zone, and I stand before you ready to receive your rotten tomatoes. But this is the kind of thing that we could do. In theory, if we were to have the patient's language, patient's educational level, patient's willingness to receive information, we could, in fact, give them information in their language, on their own educational level, and be able to provide them with even greater empowerment. How so? They go into their record and imagine depression, the word depression, becomes a hyperlink. And the hyperlink then carries them to local services that are available if they want, a brief description of what pharmaceutical options we have to treat it and what constitutes that, a brief description of the DSM. Remember, this is in their language at their educational level. Like, you can imagine what's going on here. So all of a sudden, the record becomes much more than a record. It's an educational tool, and it's a tool that empowers patients. Think about that. Think about how that could save family doctors tremendous amounts of time. The patients come in, they are already empowered with the knowledge that they have read. They understand your perspective, having read your perspective, and all of a sudden, the visit transforms. It transforms much for the better, much for the better. Remember your other ear. Now you're that patient. You want your information, and you want it when you need it. You're in Ireland, you want it, you have it. The best primary care systems in the world, incidentally, in Israel, and I'm proud to say, in Israel, all of your information is right on your health card. It's right on that frigging health card. The doctor literally puts it in and sees your entire record. And I challenge Canada, how dare us? How dare us not do that? We owe it to our patients to do that. It is not enough to say, we'll do it, we'll get around to it. As you well know, medicine lags not just a little behind, but far behind where we should be in terms of providing patients with access to their clinical records. So I hope you've learned something today. In the information you've been given, there's this article which was published I'm so grateful to Dr. Joel Lection, who helped me with this, and he's an emergency room doctor and also a well-known author in Canada on patient empowerment. And I'm hoping that you'll read it. And I'm hoping to galvanize you into becoming a very proactive part of this movement. We can help patients well beyond what we are now doing. And I'll share with you, as you well know, that person is connected to other people. The learning we provide them extends to their families, extends to their loved ones. It's not just them. When we do this, we help a universe.
Thank you very much.
Thank you.
Our next speaker is Dr. Esther Sternberg, MDCM in '74. Esther currently holds the inaugural Andrew Wheel. In no 94s, right? Just anyway. She currently holds the Andrew Wheel Chair in Research for Integrative Medicine and is the Research Director for the Andrew Wheel Center for Integrative Medicine at the University of Arizona in Tucson. She has advised many high-level organizations, including the NIH, the U.S. Congress, and the World Health Organization. She is recognized for her discussions on the science of mind-body interactions in illness and healing and the role and the place of well-being, in addition to authoring 2 popular books on the subject, has been featured on several radio and television shows. This is going to be very fascinating. Esther will join us today to discuss the future of preventative medicine and how wearable health factors into our understanding of environment and health. Welcome, Esther.
So, thank you. I assume those were my classmates for the shout out. Thank you so much. It is really an honor and a privilege to be back speaking in this auditorium. I haven't been here, I think, for 50 years. It's a thrill also to have been trained at McGill through my medical training and also as a rheumatologist. And I'll tell you a little bit about how I got to do what I'm doing, because it doesn't really sound like rheumatology. Disclosures, I have a subcontract from Lockheed Martin through the Intelligence Advanced Research Projects activity, which those of you who know what DARPA is, this is the intelligence community's DARPA. It sounds like a private sector contract, but in fact, all of the data is owned by the Office of the Secretary of the Director of National Intelligence and will eventually be made public when we're done. As you've heard, I published 2 books and eventually speak about these books occasionally. You will hear a lot about wearable technologies. What is heart rate variability? How do your wearable activity and stress monitors work? And you'll hear about how we are linking health outcomes to environmental measures in real time, and how that will eventually inform how we respond at every moment of our lives as we walk through place and space. Now, not necessarily space the way you heard about it from Dr. Dave, although it certainly can be applied to space, but anywhere that we are. So this is the vision. When I left the NIH, I was at the National Institutes of Health for 26 years as a senior scientist and section chief, studying the science of the mind-body connection. And when Dr. Andrew Weil recruited me to create a research program for the Center for Integrative Medicine at the University of Arizona in Tucson, I said, I'll come if I can create an institute on place, well-being, and performance, linking the College of Medicine, the Center for Integrative Medicine, and the College of Architecture, Planning, and Landscape Architecture. That's really interdisciplinary. But it takes a group of interdisciplinary experts to develop these kinds of measures for health and well-being, and to develop interventions that can help prevent disease. So the 2 parts of this institute, the 2 types of research that we're doing, are a sweat biomarker research program, and I'll tell you about that in a moment, and we're working with various arms of the federal government, the General Services Administration, IARPA, and others, to measure the impact of environmental variables on health, well-being, and performance. Imagine, if you look at this image, that as you move through any environment, you are carrying with you every single environmental attribute to which you're exposed. The light, the sound, the airflow, the greenery, the views, and all of that is impacting and affecting individually many different aspects of your health. Your psychosocial responses, your behavioral responses, your physiological responses, your molecular responses. So how do we measure that? And how do we take that information and help us prevent disease? So before I tell you about that, I'll say, how did I get here? So how does a rheumatologist get to do this weird stuff? Well, it all started a couple of blocks up the hill at the Montreal Neurological Institute. I was in my final year of my rheumatology fellowship training at the Royal Victoria Hospital, and I was called to see a patient at 4 o'clock on Christmas Eve in 1988. 1978. Woo! And I have to say, I was a little irritated with the surgeons. I'm sorry that Dr. Dave is gone, because it was an emergency consult, 4 o'clock Christmas Eve, by the neurosurgeons. The patient had been in hospital for 3 weeks, and you're shaking your head. And they suddenly decided they needed to know whether he could go home for Christmas the next day. I had been planning to go on a ski vacation. It didn't work out because I went to see this patient, and it was getting dark. It was 4 o'clock in the afternoon. I stood at the door of the room, and he was in excruciating pain. He had the sheets tented up over his legs. He couldn't bear for the sheets to touch his legs. When I examined him, his skin was scarred, pocked like an orange. He couldn't extend his elbows beyond about 30 degrees. He couldn't bear to move. He had been given an experimental drug for epilepsy, for a very rare form of epilepsy called intention myoclonus. And the question that the surgeons asked was, is this drug that we gave him related to this horrible autoimmune scarring disease that he developed? And what I realized at 4 o'clock in the afternoon on Christmas Eve is I didn't know the answer to that. Now, for those of you who grew up in a more recent era and you could just look on your smartphones and do a quick Google search or a PubMed search, you would know the answer in milliseconds. I had to run to the Royal Vic Medical Library all the way across the bridge over to the other end of the hospital to plead with the librarian to stay, because she was closing the library up for Christmas Eve, and to do a PubMed search, which you did on a teletype machine linking to the mainframe in Ottawa. I see some of you nodding that you remember these days. Anyway, the bottom line is that patient convinced me that doing something to the brain can affect the immune system. And it launched me on my career, where I eventually ended up at the National Institutes of Health, and I discovered that the brain's stress center, the hypothalamus, is important in susceptibility to autoimmune inflammatory disease in rats. Now, if you prove that in rats, the naysayers, who at the time said, oh, the brain doesn't have anything to do with the immune system, the science of the mind-body connection is just shishi-foo-foo, it's not real. And so, but when you can prove it in rats, the conventional medical establishment began to believe it. So I and a number of other researchers in the 1980s, early 1990s, proved that there are many connections between the brain and the immune system, and that those connections are important for health. If you maintain those connections, you get health. If you break those connections, you get disease. So my focus has been on the hypothalamic pituitary adrenal axis, where cortisol is released from the adrenal glands and turns down the ability of the immune system to fight disease. It doesn't completely shut off the immune system. It tunes down pro-inflammatory cytokines and tunes up anti-inflammatory cytokines, so there is a shift. So that is okay in small doses. But we are exposed to many, many different stressors throughout the day. And if you add up those stressors cumulatively, it's called allostatic load. So imagine you wake up in the morning and you have an empty sack on your back. And every single stressful event you put into that sack, and as the day goes on, you are weighed down by that heavy sack of stressful events. That's allostatic load. And it is the cumulative allostatic load of stress that causes disease. More frequent and severe viral infections, lower take rate to vaccine, speeding of chromosomal aging, speeding of cancer growth, and slowing of wound healing. Stress does not cause these diseases. Stress impairs your immune system's ability to prevent and to repair, and therefore you are more prone to these diseases. But you need your stress response to perform at peak. Stress response is the fight or flight response. It gives you that focused attention, that energy, that ability to do the job that's needed to be done. So you need that stress response in order to perform at peak. The problem occurs if you have too much of it and you fall over the edge of that relationship, that curve of stress response and performance. And this is true with any biological system. Too little is not good, too much is not good. Certainly for the immune system, if you have too little, you have infection. If you have too much, you have autoimmune inflammatory disease. So the challenge is, how do you detect the system before it begins to fail? How do we know before the system fails? And you heard a little bit about it from Dr. Dave's talk. And I'm going to speak, this is what I'm going to speak about for the rest of the talk. So it's the grand challenge. How do you do that? Because that's how we prevent disease. If you can't detect when the system is going to fail, you can't intervene and implement the kinds of interventions that will prevent disease. So this comes back to this, what I call the layer cake image of looking at what can we measure non-invasively in terms of the immune system and the physiological, behavioral stress responses and so on. So we established this sweat biomarker program, which we're working with the Air Force Research Labs and other agencies of the US federal government to eventually develop wearable devices to measure biomarkers in sweat without the need to draw blood, and continuously. So this will achieve that vision of being able to measure all of your responses, including your molecular responses, as you move through place and time. So in order to do this, we have to do the basic translational research. So we've established a stress challenge, sweat collection, and stress correlation lab at the University of Arizona, where we put people on an exercise bike in warm and humid conditions. Some people say you could just go outside in Arizona, but it's dry, so you have to do it inside. And we expose them to various kinds of stressors, mostly exercise, but also anxiety and also social stress and pain. So this is one of our post-grad research assistants, David Goldstein, who's sitting in the device, all hooked up. We can measure heart rate variability, breathing, carbon dioxide, temperature, and various aspects of the environment. And we collect sweat. I have a wonderful analytical chemist who jerry-rigged with, some of you might recognize that's a breast pump, to be able to collect sweat as the droplets appear. Now, that's really important because in order to understand what a biomarker in sweat means, you have to be able to correlate it at the exact moment in time with all the other physiological measures that we're measuring. So we can do that very accurately. So why cortisol? Why are we focusing on cortisol? Well, I told you about the hypothalamic pituitary adrenal axis and the role of cortisol in the regulating the immune system. But why look at it in sweat? Well, first of all, cortisol is present in much higher concentrations, we have discovered, in sweat than in plasma. We can measure the entire cortisol metabolic pathway, and I'll show you that in a moment, using LCMS, liquid chromatography mass spectroscopy, in spectrometry, in sweat. And cortisol is extremely stable in sweat. It stays there. It doesn't get broken down. This is the entire cortisol metabolic pathway that we can measure in sweat. And what we think we're seeing is the ability of the body to produce cortisol and then to clear it. Because once you get to the right side of the pathway, the inactive products, you see that the cortisol is being cleared from the system. What you see here is a resilient pattern of cortisol production and clearance. This participant quickly, in response to exercise, pushed up his cortisol and then quickly brought it down. And he brought it down in relation to the metabolites being cleared. This participant on the right-hand side, my right-hand side of the slide, is not effectively pushing out cortisol. It takes him a while to bring up his cortisol, which is required for the stress response, and the metabolites don't clear so quickly. It turned out that that person on the right was a non-athlete, whereas the person on the left, my left, right, left, was a triathlete. So we believe that by looking at cortisol and the entire metabolic clearance pathway in sweat, we can actually detect resilience patterns in different people. We can measure a number of other biomarkers in sweat. I'm not going to go through the details in the interest of time, but looking at all of these biomarkers together is giving us a window onto the stress response in real time and without having to draw blood. Well, what about place, well-being, and performance? For this, we're using existing wearable devices to measure the physiological stress response. I'll show you that in a moment. The activity, posture, sleep quality, and so on in relation to up to 11 different environmental attributes. And I started on this project when I was at the National Institutes of Health, and the then director of research for the General Services Administration that builds and operates all non-military federal buildings in the United States, over 370 million square feet of office space and over 1 million office workers. Kevin Kampshire came to me and asked if I could help him measure the impact of the buildings that they were building on health, well-being, and performance so that their over 1 million office workers could be happy, healthy, and of course productive. And so we did this first study published in 2010 where we looked at a federal building that was being retrofitted, and the old space was dark, dingy, musty, no views, high mechanical noise. The new space was light and airy with better airflow and beautiful views. And we hooked the office workers up with what were then, as Dr. Dave mentioned, very clunky heart rate variability monitors with wires and so on, but they were happy to wear them. And we found that the workers in the new space were significantly less stressed than the workers in the old space, and that they also were less stressed by measuring salivary cortisol throughout the day. So on two completely different physiological stress measures, the workers in the new space were less stressed. Now you may say, oh, well, big deal. You know, of course. But people were not subjectively aware of the difference. We also found differences in sleep quality at night. Fast forward to after I moved to the University of Arizona at Tucson, and I established the Institute on Place, Wellbeing, and Performance, and we continued the work with Kevin Kampshire, now Director of High Performance Federal Buildings for the GSA, in a project called Well Built for Wellbeing. So we looked at a number of federal buildings. That building up on the top there is the GSA headquarters in downtown DC. And we fitted people up with the new generation of heart rate variability monitors. That's a chest-worn device that you see there. We worked with a company called Aclima in the Bay Area who developed the methods to stream massive different data streams of up to 11 different environmental attributes. And we also sent questions to the smartphone. We also looked at the office layout and compared differences. Now, just one word about heart rate variability, because any of you who are wearing, how many of you are wearing these Fitbit or whatever monitors? Okay, it's interesting, not that many. I forgot mine. I usually wear mine, and I forgot it this morning. So heart rate is your heart rate. Heart rate variability is the variability between the beats. As you inspire, your heart rate increases. As you exhale, it decreases. And that's telling you something about the status of the vagus nerve. The vagus nerve is the relaxation nerve. It controls the relaxation response. The adrenergic nerves, the sympathetic nervous system, control the stress response. So heart rate variability with the algorithms that translate it tell you something about the balance between the sympathetic and the parasympathetic nervous system. It tells you only about that. It does not tell you about cortisol or the neuroendocrine stress response. It tells you about that. It tells you about your activity as you move. It tells you about posture. It tells you about some of these things, tell you about sleep quality. But what is the way to remember this is what is the single worst heart rate variability pattern that you can imagine? A straight line, correct. You do not want to have a straight line. And high heart rate variability is good for you. So we published a paper last year where we looked at the office layout, and we found that people in open office settings were 32% more physically active than people in private offices, and 20% more physically active than people in cubicles. And the people who were more active in the office during the day were 14% less stressed at night when they went home. Now, 14% less may not sound like a whole lot, but if you add it up day by day by day, it is cumulatively in a medically relevant range. And certainly the difference in physical activity can amount to a difference in 1,000 steps more per day. So your office could be your new gym. Now, once again, when we asked people with questions immediately to the smartphone, we found that people who were in open office, cubicles, or private offices, in the moment, reported that they did not find a difference in their ability to focus. Whereas after the fact, if we asked them to tell us how you felt in these different spaces, uniformly people in private offices says they were more focused. People hate open office settings. This paper had the highest media rating ever for the journal we published it in, and was the top 5 for any paper. And it's because people really care about their office space. But when I say open office, I don't mean just a field of desks. I mean many choices. This is an example of one of the federal buildings where people can have private spaces, small group meetings, and their open office setting. This is an example of a company in the Bay Area that also has these many choices. So what about the air you breathe? In the course of these studies, we discovered that we carry around with us a carbon dioxide bubble. As you exhale, that carbon dioxide accumulates in front of your face. And if you're it can be easily dissipated with a fan. It differs with posture. Why is this important? Well, the more people there are in a room, for the longer period they spend in the room, carbon dioxide increases if the ventilation system is not working well. Why is that important? Well, ASHRAE standards, which are the standards that set how high carbon dioxide should be in a given space, say that between 500 parts per million and 1,500 parts per million is fine. Well, it turns out at about 600 parts per million, you're at 100% cognitive performance. At 900 parts per million, you're down to 85% cognitive performance. And at 15 parts per million, you are at 1,500 parts per million, you are down to 50% cognitive performance. So what I like to tell people, 2 minutes left, is that if you're falling asleep, it's not my fault, it's the ventilation system. So there are many design solutions to prevent disease. And this is important because we spend 90% of our time indoors, and anything we can do to design the environment to reduce disease is important. In the interest of time, I'm not going to go through all of these, but these are elements of the design that can be changed. The General Services Administration is already instantiating this into tools and recommendations for the design of office space. I'm going to show you quickly something about hospital design. We know that views to windows and trees are healthier. We know this from 1984 on, and over again, there are many studies that have shown this. What is good for the bottom line, what is good for the patient turns out to be the bottom line. If you spend more money to build such a hospital, you will have better health outcomes and cost savings. The military is mapping onto this in a big way. This is an example of a labyrinth, which is basically a walking meditation at the National Intrepid Center of Excellence. This is very important for healthcare and aging in place, to include all of these kinds of design interventions to allow people to extend their independence, and that includes smart devices and smart homes that you heard about. I'm going to show you very quickly some data from a study we're doing now at the Banner University Medical Center Hospital, this is the old hospital that was built about 40 years ago. This is the new hospital in Tucson with beautiful views of the mountain. We did a similar study to what I showed you for the GSA with different devices, and we also tracked the nurses' movement through space. And this shows on my left, your right, the movement of one of the nurses through this ward. You superimpose it and you can see where she was moving. You look at a number of nurses and you see that one of them is moving a lot more than the other. Why is this important? This is important because design professionals can now take this kind of data and use it to design better space so the nurses have less workload, less pain, and hopefully better sleep quality. We're also looking at sleep quality using a wearable device. The blue area is the time they're asleep, but the black lines are when they awake, and you can see that this nurse was waking up a lot during the night. If we can design the physical environment to improve sleep quality when people go home, when workers go home, you will improve health outcomes for patients, for the staff, and quality of life. So I'm just going to end with a couple of slides here. The future is smart. This is an example of one of the smart chairs and wall coverings that are being designed by Alethea Ida at the University of Arizona using bioresponsive materials to optimize individual temperature and humidity for each individual. It happens to be hard to do that, and we're working on that at the University of Arizona. This is the project I mentioned earlier with IARPA. This all requires huge big data analytics. Without the data analytics to interpret the massive amounts of information that you're getting, you cannot do actionable interventions. So this is my vision of the future for preventive medicine, connecting human health outcomes, human health measures in real time with environmental measures and automatically adapting your own environment for your own health. And so those of you who remember Get Smart, or this, for those of you who are a little younger, instead of that cone of silence that descended on these players, imagine that you would walk into a building and have your own cone of perfect environment descend on you to optimize your health, well-being, and performance. So that's how I see the future of medicine. Thank you.
Thank you very much.
Thank you.
Our next speaker is Dr. Michael Viola. Dr. Viola is from the class of 64. Unbelievable. Do we have a shout out for a 64? Michael is both a physician and activist, focusing his career on international development work, founding the medical and relief agency Medicine for Peace, MFP. MFP has focused its efforts on providing patient services during the wars in Iraq and Bosnia, and most recently established a cervical cancer detection program in Haiti. He received the 2018 Medicine Alumni Global Award for community service. He's an example of that a physician can not only treat, but can also identify human rights abuses to aid in the efforts of improving overall population health. Michael will join us today to discuss political, security, and infrastructure challenges to delivering medical care in the developing world, with reflections on MFP's cervical cancer screening program in Haiti. Welcome, Michael.
So this will be a bit of a departure from the previous talks, but connected in some ways. So I'm going to talk about impediments to delivering health care to developing countries, and specifically about a women's health program that we started in Haiti about 9 years ago. In fact, on March 8th, 2020, we'll have our 10th year celebration, and Haitians tend to celebrate these things in a big way. This photo is of two Haitian women, appropriately, welcoming the morning, saying their morning prayers. And it was taken, as are many of these photos, by Medicine for Peace volunteers. Lots of folks have gone to Haiti. Church groups love to go to Haiti, and so many of you have perhaps been to Haiti. And most people who talk about Haiti dwell on the misery that you find there. And I think what's neglected is the fact that it is a gorgeously beautiful country, particularly in the countryside. Deforested as it is, as you can see here, it almost has a mystical beauty. Everyone comments on the beauty of the land who spent any amount of time there. I'm going to crystallize these learning objectives for you in really one sentence. There are two primary structural obstacles to delivering health care in Haiti. The first is poverty. Women do not have money to pay for health care. Nothing is free in Haiti. Education's not free, health care's not free, and it always comes down to a woman having to either take what little money she has and put food on the table, or do something else, educate her children, or go to the hospital if she has vaginal bleeding, for example. So poverty is the main culprit. The second is a failing government. The government in Haiti, as in many governments in the developing world, is failing. It does not provide services, people, or facilities to support the health of its population. So I'm going to mention all of these as we go along and touch on some of the ways we've tried to address those challenges. So Haiti is only an hour and a half from Miami. It's 700 miles. But it is the poorest country in the Western Hemisphere if you use UN Development Index, which is a composite index of health, earning power, and education. It ranks among the lowest countries in the world in a cluster of countries in Africa who are either at war or are suffering drought. So Haiti is in big trouble in terms of development. There's another health inequity in Haiti, and that has to do with where you live. The population is about 11 million people, and over the past 2 decades, there has been a rush to the cities. Now more than half the population lives in urban rather than rural areas, and accounts for the fact that why there was such a high mortality during the 2010 earthquake. Many of the folks who died during the earthquake had just arrived in Port-au-Prince, were living in substandard, crowded housing. And it's all because of the failure of the agricultural sector, which forced people to come to the cities to try to make money. And that is a complex issue, and the Western countries, Canada and the US, have their hands in that as well. It's not just Haitian incompetence. So we decided to work in Gros Morne, which is about 4.5 hours north of, I should have showed it to you on the map, but it's about 4.5 hours north of Port-au-Prince. And this hospital was one of the reasons. It was built about 40 years ago by a German priest. It has a religious name, the Alma Mater Hospital, but it is not supported by the church anymore. It was the only 24-hour-a-day health facility in the northern Intibonite region, and it services a population of about 140,000 people. In the town itself, there are perhaps 30,000 folks. To the right of the slide is, so this hospital is where we've worked for more than a decade. The hospital has been open constantly through 3 hurricanes. And the only time we really shut down our women's health program was during the cholera epidemic. And here's the cholera tent in the upper portion of the photo, and people who were perhaps less ill and could take oral rehydration salts were treated below in the atrium of the hospital. So there were 900,000 Haitians who suffered cholera in 2010. It was the largest cholera epidemic in the world. It has now surpassed to Yemen. And we've actually controlled cholera. I haven't seen a case of cholera in this hospital in about three weeks. And I show this only to show that Haiti and countries like Haiti, impoverished countries, are very fragile. They cannot tolerate a stress like this in their society. They have very high mortality rates. I think the earthquake is a good example. There were a similar magnitude earthquake. There were over 200,000 people who died in the 2010 earthquake. Similar earthquakes occurred in Chile, which had a more stable structure, interestingly. Only about 500 people died. In New Zealand, the same magnitude earthquake and no one died. So this is a very fragile society. It cannot tolerate either natural or man-made disasters very well. And that represents an obstacle in improving the general health of the population. So why women's health? Well, women have a very, very interesting position in Haitian society. They usually are the breadwinners. They take care of the children. They take care of the sick. They take care of the elderly. They're called the pitometan, the pillars of society. And when a Haitian woman gets ill, things start crumbling, not only in her family, but in her whole community. The mean income of these women, they're called the small merchants who are working in the Gromon market, is below the extreme poverty level. And half of the people in Haiti live in extreme poverty. That means that they do not know where to get money to get food to put on the table that night. Literacy rates are rising, but still half the women who come into our clinic sign a consent form with their thumb. They cannot read or write. Family sizes are large. And if you ask a woman who comes to our clinic, do you want to have another child? And she says no. She said, and the next question is, if we gave you free contraceptives, would you accept them? She says yes. Well, she satisfies the need for unmet contraception, and that's high in Haiti. That's about 45%. So the other bad news is the maternity, other indicators of female health, maternal mortality, infant mortality, and in Haiti, AIDS infectivity, are very high. Again, some of the highest in the Western Hemisphere. But over the past two decades, they have dropped considerably and continue to drop. And there are a lot of reasons for that. Part of it is education. But in general, they're dropping too slowly. We became interested in or found a way to sort of begin to address women's health in Haiti with treatment of cervical cancer. We don't know what the true rate of cervical and breast cancer is in Haiti, but we know it's very high and probably the leading cause of death of women between 25 and 60. One often thinks of infectious diseases as being the leading cause of death in Haiti, but that doesn't happen to be the case. And as you know, 85% of the world's cervical cancer cases occur in the developing world. It has become a disease of the poor. So I'm going to mention how we started the program, how it evolved, and what I think are the critical aspects to its success. And its success is in this picture. This is our clinic on any morning. You notice a lot of these mothers have their children with them, and cleverly, we always schedule clinics on the same day that they have the vaccination program. So they're sure to come. Haitian women are smart. If you give them health care, they will accept it. There's a Creole saying, "An alphabet pas bête," which means we may be uneducated, but we're not stupid. And I think this shows that. So we use the standard method that's used in the developing world for screening cervical cancer, that is visual inspection of the cervix by colposcopy after treatment with acetic acid. Dysplastic lesions show up as white plaques at the squamocolumnar junction, and they are immediately treated with cryosurgery. This is over-treatment because some of these lesions are low-grade lesions, probably could be watched for a while, but a patient who we never leaves the clinic, who we detect having a presumed dysplastic lesion. One of the dictums of screening programs is never screen for something that you're not immediately prepared to deal with. So this hospital has essentially none of the facilities, the infrastructure that we needed, and we had to build a sort of virtual hospital. That is, we needed histopathology and cytopathology we found in another hospital in Port-au-Prince. We found collaboration with a radiology group to stage our patients by CT scanning and doing our mammography. And we had to start interviewing physicians to find physicians who we thought could do a good cancer operation, a good mastectomy, and a good radical hysterectomy. There is no radiotherapy on the island. Well, there's a radiotherapy unit in the Dominican Republic, but there's no radiotherapy unit in Haiti itself. So you get one chance. You get a stage 1 or 2 lesions, and you have to get it to a good surgeon. So we're doing colposcopy, and we're seeing a lot of sexually transmitted infections. We treat primarily on clinical grounds, except that we do screen for HIV in the laboratory and for syphilis. And we see a lot of cervical vaginal infections. So if you're going to screen for precancer, you're going to see you're going to detect invasive cancers. You're either going to treat them or they'll be inoperable. And about half of the patients we see are inoperable, which means who's going to take care of them? So we had to develop a palliative care unit, which means we take analgesics, food, and any other medication the patients need to their homes. And I'll show you a photograph of that. And lastly, and why this happened lastly, I don't know, but lastly, the clinic developed a family planning and counseling unit. The preferred method of contraception among Haitian women is Depo-Provera, but a lot of counseling has to be done. There's a lot of social stigma attached to contraception. That I see is changing with the AIDS epidemic. I think women are much more savvy, much more interested in safe sex, and much more interested in decreasing their family size. So what make this all work? In one word, it's all free. We pay for all of it. We pay for the visits, the surgeries, the medication. When a patient has to go to Port-au-Prince for an exam, we have our van take them to Port-au-Prince. We wait for them to get their exam and to come back. Basically, we've seen too many people die in Haiti because they have no money. So we've tried to leap over that argument, and there is an argument about having patients pay for health services. I just left that far behind. So it's free medical care. I'm going to show you rapidly a few slides on what I thought were the most important aspects of why this now has been going on 9 years and probably will be going on for another 10. The first is that you had to engage the stakeholders, and this is a meeting on March 8th, International Women's Day, when we kicked off this program in 2010. And Haitian women may be suppressed, they may be bullied by their males in their household, but they know how to organize. And in this room we collected the Women's Water Committee, the Women's Teachers Committee, the Women's Peasants Committee, the Women's... They're all in this room, and they're in this room because of the presence of this woman in the front with the brown shirt on, Gerendal Falusma, who was the only woman who was in the Haitian House of Deputies. So that tells you something about Haitian politics. So Gerendal was a great proponent of this program. She demanded that the women in her constituency own this program, and we've kept these groups engaged and since the very beginning. Sorry. Education. We have there are 2 radio stations in Gromont. We're on the radio stations all the time. We're in the pulpits. And here's one of our volunteers in the market trying to explain to a woman why she has to come and get an exam and giving her a free ticket. She didn't really need the free ticket, it's free. But, you know, much of education goes on by word of mouth, you know, woman to women in the market. So after about a year, we realized we were only capturing women who were about 5 or 6 miles from the hospital, and we decided to start a mobile clinic. So once a week, we pack everything into the ambulance, the hospital ambulance, and we go to there are 10 dispensaries in the mountains which is a wonderful day traveling through the mountains of Haiti. And here is one of those clinics, a beautiful spot called Pondu. And two of our nurses, we have a community health worker who prepares our arrival, gets all the women ready for our arrival. And these two women are lecturing people who live in Pondu on how to make good health decisions, how to get control of your reproduction. It's not an older woman who makes that decision for you. It's not a man who makes that decision for you. It's you have to make that decision. And also decisions about how to take care of your children. These folks will all get exams after the lecture period. One thing that's really changed, and if any gynecologists in the room, you know this technology, but one thing has dramatically improved the quality of the care is that on the left, that white instrument is an old-fashioned colposcopy. We had to carry around electrical generators to provide electricity for the light. We've now switched to a sort of handheld colposcope, which is battery-driven and has an embedded cell phone. So every image that we take in the most remote hamlet of Haiti is downloaded into the cell phone. There's an irony here. Haiti has very poor sanitation, very poor. There's no electricity where we live. There is, we struggle with potable water, but we are wired to the hilt. Digicel, the Irish communications giant, has towers everywhere. So everyone has a cell phone. You can just, they cost nothing in the market. So we're well wired, and we use that. So all of these images are in the cell phone. They are downloaded into a secure site on the internet, a Medicine for Peace site. All of our consultants in the United States, elsewhere, who have access to this. This can be done in real time, so I can be in Washington watching an examination in a little village in Haiti. And it's been a boon to quality control because we review every image collectively with all of our folks. And also, having internet access means that we can move reports back and forth very quickly and I think have a very high standard of care. So here's the palliative care team. We're out about 6 miles from Gromont. This woman is a mother of a patient we've come to see. I think all you need is, well, palliative care is difficult, but basically you need caring nurses, people who understand the suffering that the patient is going through. So every Friday afternoon we're making our visits to patients who have inoperable cancer. So in the first 9 years of this program, we've seen over 7,000 new patients in about 5%, which is about standard for high-risk areas. We're subjected to cryosurgery, and we've seen a lot of cervical cancer. And I think they were, as I said, half of the patients were advanced and probably just waiting for the clinic to start to come see us. We follow all these patients. And we still have to screen for AIDS. We still detect a lot of HIV-positive patients and new syphilis patients and treat a lot of cervical vaginal infections. So the important thing is not the quantitative aspects of this data. It's that all of these women have been brought into the healthcare system. When they get pregnant, they will undoubtedly go into the prenatal care program. Then when they deliver their children, they will have birth attendants with them, which their parents probably did not have. If their kids get sick, they know there is an oral rehydration program. If their kids are a little underweight, we have a nutrition program. So So the whole idea is when you capture a woman for one thing, like cervical cancer, you basically just have to bring her in and make sure she's ready to make healthy decisions. That leads me to my last slide. So the underlying theme here is that the Haitian government has not provided any of these services which they should have. And I think an even more important failing of the government is that the education system is so poor. Only 20% of girls in our town will reach 6th grade. Now, we know really from lots of investigators, but I think the best from a population expert named Wolfgang Lutz, is that there is no better indicator of the health of a society than how you educate young girls. And it's incremental. For every year that a young girl goes to school, she is likely to live longer, her children are likely to live longer, her family will be smaller, her maternal mortality will drop. And if you're lucky enough, like this young Haitian girl with attitude on the right, who is, she's going to go to secondary school. If you can get a girl into secondary school, their lives will change forever, as will their children. That's when they start thinking about making hard decisions about their life. I would say that we, our partner, the Children's Scholarship Fund for Girls, have been supporting girls like this, and she's one of them, for 20 years. But it's more than just for a nonprofit, an NGO. It's a government responsibility. The government of Haiti has to provide free and compulsory education, at least till 6th grade. It's the only way the society is going to change. I hope I've piqued your interest a little bit in this kind of work, either here in Canada, or serving the underserved, or in the US, or elsewhere. It's a wonderfully satisfying work, and if you can't participate, I would encourage you to support. There are a lot of good agencies around to support who do this kind of thing. Thank you.
Thank you very much, Michael. Our next speaker is a classmate of mine from the class of 1984, Dr. Joel Wolkowicz. Shout out from 84 for Joel. Joel is a practicing cardiologist and a specialist in internal medicine. He's the regional director of cardiology, University of Vermont Health Network, and he actually specifically requested I say Plattsburgh, all and around Plattsburgh. He's served the cardiac care needs of North Country patients since 1994 and has held the position of medical director since 2008. Joel will discuss the misuse of statistics in published research. Welcome, Joel.
Thank you, Brent. That's not a picture of me. I wish I could age the way the Strathcona Medical Building does, but that's not going to happen. It is humbling to be speaking after that lecture by Dr. Viola. Really gives us pause. And hopefully everybody wakes up grateful for what we've got here. I have no disclosures, no conflicts of interest. As Brent said, I'm a cardiologist. I'm neither a researcher nor a statistician. But I'm going to be talking about some of the ways in which statistics are misused in medical research. I'm going to try and help you pick out some of these problems, maybe help you be skeptical even before you've seen the results of a study, and then end with some of the ways that maybe we can be a little better at this. This article was published by Dr. John Winides in 2005 in the Public Library of Science. Very provocative article, very provocative title. And it took me back to an article I remember reviewing one of my medical student classes. This article was published in what's that? This article was published in 1981, the New England Journal of Medicine, so I was a first-year medical student at the time. I want to point out specifically that the lead author was Dr. Brian McMahon. Dr. McMahon was for 30 years the director of epidemiology at the Harvard School of Public Health, and some called him the founder of modern epidemiology. He took a leading role in epidemiology of breast cancer and secondhand cigarette smoke. So this is his article. And fairly simple design. He and his colleagues took about 500 or so patients with cancer of the pancreas. They compared them to 500 control patients who had other diseases but not cancer of the pancreas, and looked at 4 variables: exposure to coffee, tea, alcohol, cigarette smoking. And what they found in standard analysis was a borderline positive result for cigarette smoking, no relationship between alcohol or tea, and a strongly positive association at p less than 0.05 between coffee and cancer of the pancreas. So let's take a step back for a second. We've all been taught, and I think most of us still believe, that if you get to the p less than 0.05 value, you've got a statistically significant result, and that's when we all stand up and take notice. So that would be about a 1 in 20 chance, or about a 5% chance that something would happen by chance alone. That's how we were all taught. So what are the chances that we are going to find in this article, in this study, a statistically significant at the p greater than less than 0.05 level, that coffee is in fact associated with cancer of the pancreas? If in fact that's not true, in other words, the null hypothesis is correct, what are the chances that we get this result and it's a false positive result and the null hypothesis is in fact correct? So if we were only comparing coffee and had a single variable, we would be at that p 0.05 level, 5% chance. However, we didn't just make, or they didn't just make a single comparison. They looked at 4 different variables. And so in fact, you have to modify the equation a little bit. N up there is the number of variables. If n is 1, then you're back to 0.05. But if n is 4, you're actually at about a p-value of 0.19. So about a 1 in 5 chance, a 20% likelihood, or 19% probability that in fact we were going to find that one of these 4 variables is positive at the p less than 0.05 level. So at this point in time, the results are actually not striking, not significant, probably not even publishable. So that gets us back to my talk. Now, this talk, as I said, this article, as I said, was published in the premier medical journal then and now by a premier epidemiologist, very prestigious guy. Not only did they publish, but look at what I highlighted, the last line of the abstract. Again, very provocative. Coffee use might account for a substantial proportion of the cases of this disease in the United States. This is back in 1981. We didn't have wall-to-wall cable coverage. We didn't have social media. But it caught on. And the medically naive and statistically naive press made a big thing about this. This I stole from a book I read recently by Jordan Ellenberg, and it highlights the same issue. So in this cartoon, we've got a young lady who's running up to this young man saying that jelly beans cause acne. And he calls out the scientists to come investigate. The scientists are actually playing Minecraft, but reluctantly agree. Scientist comes back, the scientist has the lab goggles on, says no relationship between jelly beans and acne, p greater than 0.05. So young man says that settles it, and then the young lady comes back and says, I hear it's only certain colors that cause acne. So he calls out the scientists again. Scientists come back, they tested brown jelly beans, no relationship with acne, p greater than 0.05. They test salmon color jelly beans, no relationship. Teal, they test a total of 20 different colors, and none of them reached a p-value of 0.05 except for one, and that's green jelly beans. Now, some people are giggling, and that's good. I think you get the point. If you test 20 variables, by chance alone, you expect at least one of them to reach the p.05 level. But the medically naive and the statistically naive press and public doesn't understand that. And this is what the front page of the New York Times is going to look like the next day. So this gets me back to Dr. Juanidis' article from 2005. He talks about it prosaically. He also goes about it statistically. It's not very complicated statistics, it's just algebra, but I'm not going to get into it. And then he does something to me that's even more provocative. He publishes a second article. These are both sole authorship articles in the same year, 2005. This was published in the Journal of the American Medical Association. And what he did, he looked at the previous 15 years, articles that were published in the major medical journals that had been cited at least 1,000 times. So these are presumably articles that were well regarded, well respected. People were looking at the results and incorporating them into their thinking. He took these articles and he found a total of 49 of such articles that met his criteria. Not surprisingly, 45 of the 49 articles had positive results, because trials with negative results are much easier to do, but much harder to publish. So that's the publication bias. This is a partial list. Don't try and read it. The first 7 studies on the top were in this list of articles that were ultimately had their results contradicted. So this includes things, if you think back to the 90s, hormone replacement therapy to prevent coronary disease in postmenopausal women, vitamin E use to prevent coronary disease. This was very popular. I remember being at a conference once. The audience was polled how many physicians, this was a medical audience, how many physicians were taking vitamin E. Probably 50% of the people raised their hands. So these were very influential articles that were subsequently proven to be contradictory. The next 7 on the list were not entirely contradicted, but the initial strong response noted in the article was subsequently shown to be of lesser effect. So 14 out of 45 of these published articles, so almost 1/3, actually had results either refuted or significantly changed. And these are the best of the best articles. These are not the lousy articles in the throwaway journals. So it's really astounding, and it caught me to think, what am I reading and what do I believe anymore? Dr. Juanidis goes a little bit further. He does further statistical analysis, says that if you have large randomized clinical control trials or meta-analysis of well-performed randomized clinical control trials, the positive predictive value, in other words, the likelihood that the result is going to stand up long-term, is 85%, which means the flip side, again, 1 in 6 of the best articles is ultimately likely to be contradicted. If you drop lower in the chart, you have smaller trials, you have observational trials. The positive predictive value, the staying power for these studies, is actually less than 50%, less than the flip of a coin. When you get down to the bottom 2, these are what he termed discovery-oriented exploratory research with massive testing. So think genomic-wide testing. You're testing genes and association with a particular disease. We can test, as some of the other speakers here earlier today highlighted, we can do genomic-wide analysis of 100,000 genes in no time at all. If you continue to accept a p-value of 0.05, the chance that a positive finding from one of these testings is going to hold up is somewhere in the range of 1 in 10,000, right? Why even spend the time doing that? So he takes his data and he comes up with 6 corollaries, which are really kind of the take-home points that you want to have from his work. And I'll be going through each of these individually. The first, the smaller the study, the less likely the research findings are going to be true. This was a study published by somebody named Don Poldermans in the New England Journal of Medicine, again, in 1999. Made a big impression on me at the time as a cardiologist. He looked at about 110 patients who were going to have non-cardiac surgery. Half of them were given a beta blocker preoperatively, the other half were not. 2 out of the patients given beta blockers, so almost 4% had major complications, compared to about 30% in the control group, so a 9-fold difference, which is just phenomenal. And I took that to the bank back then, I'm going to tell you that. Turns out it was too good to be true. Subsequent larger trials refuted his results. The other thing you want to know about this is Dr. Poldermans, who was a very respected researcher at the time, was subsequently found to have falsified data, and his trials have since been retracted from the medical literature. Second corollary, the smaller the effect, the less likely the research findings are true. So think about these large databases that we've got now. And I've seen studies coming out of data mining from the province of Ontario, which has, I guess, a database of all their patients in their health insurance system, about 5 million patients. You could conceivably, I'm not saying I've seen this done, but just to give you an example, you could look for something and find something like a blood pressure difference between drugs or conditions of less than 1 millimeter that would probably end up being statistically significant because of the volume of the patients in the study. So just because something is statistically significant, it doesn't mean it's clinically significant. We want to look for something that has a significant, a clinically important effect before we get too excited about it. The greater the number and the lesser selection of tested relationships, the less likely the research findings are true. So this is what's been called data torturing. There are, in fact, some data software companies who will actually promise you if you use their software, you will find some kind of a statistical association in your data. So this gets back to what I talked about with cancer and coffee of the pancreas. We're using 4 variables, or the jelly bean and acne. You really want to have a focused evaluation. You can't just use a big net to capture anything that might swim in it. Fourth corollary, the greater the flexibility in analysis, the less likely the research findings are true. So in my world, in cardiology, we like to see trials with mortality as an endpoint. Whether you're looking at medications, bypass surgery, or stenting, we really want to see mortality. When you start getting into things like refractory angina requiring PCI or rehospitalizations for heart failure, these become fairly wishy-washy because what I consider refractory angina might not be what somebody else considers refractory angina. So we're really hoping for hard data, not stuff that can be fudged. Importantly, I think it's intuitive, but I'll say it, the greater the financial or other interests, the less likely the research findings are going to be true. So as I discussed with Dr. Poldermans, he presumably had significant academic pressures, prestige. He may have had financial incentives as well, I don't know, but he falsified his data. The big food industries are getting into this. So the makers of sugary foods or high salt foods are trying to dispute some of our findings that suggest that these ingredients are bad for our health. Hopefully nobody is going to believe if BP or Exxon comes out and says that fossil fuel consumption doesn't contribute to climate warming. Finally, the hotter the topic And along with that, it means more scientific teams involved, the less likely the research findings are going to be true, something that's been called the Proteus phenomenon. So we think back to the 1990s, and at that time, hormone replacement therapy in postmenopausal women, as well as vitamin E supplementation, those were very hot topics. Now, the first studies that are going to be published are not the negative ones. It's the positive studies that are going to get published. Nobody wants to publish a negative study unless it's refuting a previously published positive study. So be careful of the real hot stuff where the researchers come out quickly, especially if the data isn't really robust. It's not to say that all these studies have no value at all. Can you read that? Used correctly, animal studies can help cut harmful fat. Much to my disappointment, you can't even trust the guidelines. In the cardiology field, we have the American College of Cardiology, American Heart Association, who publish tremendous amounts of guidelines. So in the past 10 years, they've published 26 guidelines on major topics in cardiology, with almost 3,000 recommendations in these guidelines. It turns out less than 10% of these recommendations are actually based on good quality randomized controlled trials. 50% are observational studies or a single randomized controlled trial. And as we saw before, probably only 50% of those findings are actually going to hold up to long-term scrutiny. And worse than that, 40% are based on expert opinion alone, which means we don't even have good data. And yet these are being promulgated in guidelines that determine how we practice, and I dare say are probably being used in the courtroom as well. So where are we going from here? Hopefully we're going to have better medical journal editors. I showed you what the, I'll show you in a second some of the changes along that way. We're going to have to be smarter about the use of statistics. We can't just stop at the p-value anymore. And we're going to need smarter consumers, and that means us. We can't just read the last line of the abstract anymore. We're going to have to dig a little deeper if we want to accept the data that's presented. So I first gave this talk a few months ago to a group of residents at our hospital. And like 2 months later, the New England Journal published this. So I assume they had one of their spies in my talk. So new guidelines for statistical reporting in the journal. And they talk about many of the things I talked about. Use of p-values with multiple comparisons really isn't valid. Using a secondary endpoint as a major finding in the study. They emphasize the use of confidence intervals rather than just the p-value alone. Use of effect size so that you get some idea of what you're actually getting with the intervention, and other things. I've got a couple minutes, so I'm going to just talk about one more thing now. That's called Bayesian analysis. So we all kind of use Bayesian analysis every day when we treat our patients. So if I see a 20-year-old with chest pain who has a less than 1% likelihood of coronary disease, my approach is going to be very different than a 75-year-old with chest pain who probably has a 50% likelihood of coronary disease. So that's Bayesian analysis. This little doohickey here is a mitral clip. And it's basically a fancy clothespin. And traditionally, for severe mitral regurgitation, the only treatment was open heart surgery to repair the mitral regurgitation or replace the valve. This clothespin, mitral clip, is inserted percutaneously, and it's a fairly minor procedure. People can go home the next morning. Most people with mitral regurgitation these days, cardiology is really a geriatric practice. Most of our patients with severe mitral regurgitation are not good candidates for open heart surgery. So there was a couple of trials that have been done on this. First of all, there was actually a surgical trial some years ago where they basically sewed the mitral valve together in people who were having concomitant coronary artery bypass surgery. And turned out that didn't work. The surgical mitral valve repair group did not do any better. Then there was actually a trial of this mitral clip a little over a year ago, published out of Europe, and they found that the clip patients did not do any better. And so I personally was very surprised last year when this trial was published, called the COAPT trial, out of the United States. And what they found is that in the patients who got the clip on the right graph, they had a reduction in heart failure hospitalization by about 50%. On the left graph, they had a reduction in mortality of about 40%, which is astounding. I can't remember another cardiac intervention trial with a magnitude of effect like this. So the question is, how do we consolidate these trials with such different results? We have the COAPT trial to the left, strongly positive, the MITRA-FR trial from Europe, which is negative. So in Bayesian analysis, and I'm just going to give you the very brief bare bones here, but if you just look at the box with the graphs in it, the yellow graph would be where I was intellectually before the American trial was published. So it's right over 0 in the middle of the graph, saying probably no result, no benefit from the mitral clip. The blue graph is the results of the American trial in isolation. So all the way to that side of the graph, suggesting a very strong benefit. You can either do it kind of intuitively in your mind, or there are actually mathematical ways of doing it that are way beyond what I can discuss. But when you do that, you get something that looks like the red graph. The red graph would suggest that, yes, there probably is some benefit, but it's probably not as striking as the Americans found and as is demonstrated in the blue graph. So that would be Bayesian trial analysis. So, what do we learn? First of all, don't trust analysis of secondary endpoints. Don't trust multiple analyses if they haven't been appropriately adjusted statistically. Beware especially, and this shows up a lot, of the word trend or suggest. When somebody puts trends or suggest in their paper, it means the results were not statistically significant. So they're trying to make lemonade out of lemons. Beware of some of these genome-wide fishing expeditions. These really have to be done rigorously, otherwise we're all just wasting our time. If something seems to be too good to be true, it may be. Beware statistical significance without clinical significance. As I said, in some of this data mining that we're going to see, it's so easy to get into these large databases. You really want to be sure that you're looking at something that matters. Needless to say, beware of industry-supported studies. Nobody's going to trust Exxon on climate warming. And finally, don't be blinded by the prestige of the author or the journal. I don't care if it's the President of the United States, you don't have to trust him.
Thanks, Joel. All right. Don't go anywhere. I'd like to invite the 4 speakers up for some Q&A. We have a few minutes.
I'm struck by all your enthusiasm and abilities to look beyond the conventional way I look at things. So I try in my practice to get patients to get copies of their note. I want them to be reviewed before they get a copy. Most patients say, nah. I wear a Fitbit. Initial data on Consumer Report, you get extra 500 steps a day. Now we're saying this stuff doesn't work. I've been to Kenya. I haven't saved too many people. I keep trying. And I'm still confused about the mitral valve clip, and especially about dietary interventions and dietary studies. It's all based on association data. I still don't know what to recommend for diets, and I don't know how to figure that out. So I need some insights in all those areas.
So is this working? Yeah. So I'll speak to the Fitbit thing, and I don't want to use the brand names of any of these wearable devices. As I said, we work with the Air Force Research Labs. The Air Force Research Labs tested, this was back about 3 or 4 years ago, a number of these devices, and found that many of them were only the commercially available, commercial grade wearable devices, which are all based on heart rate variability, activity, posture, and so on, are only about 70% accurate. And as the chief scientist of the Air Force Research Lab said, as you heard from Dr. Dave, if you're up 35,000 feet in a jet, you don't want to be only 70% accurate. So the problem with a lot of these devices is they are not research grade. If you're doing research studies, you need to use a research grade device, which unfortunately costs a lot more money. So the one we used in the GSA study is this wearable device called MovieSense, and we know that that is research grade. Many of these companies purport that their wearable wrist-worn device is accurate for sleep quality. Many of them are not. And only a couple have been accurately tested in an actual sleep lab. And the data that I showed comes from one of these devices that was tested in a sleep lab to be accurate for sleep. So you have to be careful. I think that in terms of activity, they're accurate for your relative activity, not your actual number of steps necessarily, but it does tell you whether you're active or more active or less active relative to yourself. So I think that's fairly accurate. Whether you're stressed or not stressed, that's a little bit more vague. And again, some of them are tested more accurately against the gold standard. So you have to be careful. If a patient is coming to you and telling you that, oh, my wrist-worn device told me that I didn't sleep at all last night, but I'm sure I slept, it's more accurate if you listen to what the patient is saying. That said, humans are notoriously not able to really accurately report how well they've slept. So if you really want to test somebody's sleep, you have to do it in a sleep lab until such time as some of these devices, and they're getting better, are more accurate and tested.
I'm sorry, is this on? Can you hear me? Sorry, I just want to address another part of your question, Greg, and that was dietary intervention. Nutrition is extremely difficult to analyze using standard research techniques that we use for drugs or intervention. It's very hard to get a population of 1,000 people who are identical except for one item in their diet, follow them for 10 or 20 years, and get results. So you kind of have to go by the seat of your pants a bit on nutrition and use your gut, if I can say that. Most of our nutritional analysis will come from like countrywide data, so we compare Finland to France to the United States. The problem with that is we're not just comparing diet, we're comparing genetic influence, we're comparing environment. So I feel sorry for people doing this kind of research on nutrition because I think it's very hard to do with our standard methods.
Just to comment on the patient who did not want their clinical records, I think that's actually a very important perspective. Understand that at any given point in time, the likelihood of a single patient wanting their information at that moment is going to be low. We're talking about in the aggregate. So when I talk about the need for patients having their own charts at the moment of care, they define the care. It's a bidirectional model. So if that means at 2 a.m. when they're sitting in their underwear, worrying about their mom's health or worrying about their own health, they have access at that point. So I hope that answers the question. Seems like there's a lot of questions here. Oops.
Yeah, I don't think you asked me a question, but you made a statement which is an interesting one. You said you went to Kenya and you tried to save patients, but you don't think you did. I think that physicians have other roles in international health. Many human rights abuses have been discovered by physicians in the field. Had nothing to do with medicine or delivering health care. Many physicians, by their very presence, and I can think we were in Bosnia during the time of ethnic cleansing. Well, we weren't delivering health care, we just were with people who were being ethnically cleansed. And I think that your presence, a physician's presence, is a statement. It's saying, I am with the oppressed, not with the oppressor. So there's a great many roles for physicians in the world other than dispensing medication. And I think, I mean, a lot of this work used to be done by journalists. I think there are physicians in the field who are doing what journalists used to do and what Amnesty International and Human Rights Watch does. There are physicians, I know many physicians who are uncovering human rights abuses and reporting them.
Question over here. Thank you.
Yes, thank you. I'd like to ask a question about genomics and preventive health. I run a preventive health company and recently have had to really dig deep to understand if there was any real value in looking at the exome with respect to changing preventive profiles and behavior. So you kind of look at what the CDC says at Tier 1 profiles, which is FH, Lynch syndrome, and I guess BRCA1, BRCA2. Then you look at the American College of Medical Genetics, and they have the 59 genes. And then there was this publication, which makes me really nervous now after listening to your talk. Recently, like maybe it was 2 years, about polygenic risk scores in cardiovascular illness. And what really blew me away about that study was that there was, as a result of these polygenic risk scores, there was no relationship at all to any independent known risk factor that you would except maybe LDL cholesterol, that you would have learned when I went to medical school in the Framingham risk study. So from any of you, I mean, you all have probably points of view on this. Is genomics and prevention not really ready for prime time?
I'll start briefly, and then I'm going to hand it off. I'm not a genomics expert. I think you have to look at that two ways. First of all, using genomics is not going to be as easy as we thought, and we're probably going to need different paradigms to use the information that we get. And the second thing is, you know what, maybe some of the stuff we're getting from genomics is right, and some of the stuff we were taught in medical school was wrong. So it's the Wild West, and people who know more about genomics and statistics than I do are going to need to figure it out.
So I'm going to answer your question by citing the study that I did when I was at NIH to prove that the brain stress center is important in susceptibility to autoimmune inflammatory disease in rats. It's much easier to do this in animal models because you can do things like transplant the hypothalamus from a resistant strain to a susceptible strain, change their susceptibility to arthritis and those sorts of things. You can't really do that well in humans. But I was studying the two strains of rats, one that was highly susceptible to autoimmune inflammatory disease. The pattern of autoimmune inflammatory disease depended on the pro-inflammatory trigger to which they were exposed. So strep cell walls, bits and pieces of tuberculosis bacteria, so on, would trigger something that looked like human rheumatoid arthritis. Bits and pieces of spinal cord gave them something that looked like multiple sclerosis, bits and pieces of thyroid gave thyroiditis, and so on and so forth. They're called Lewis rats. On the other hand, they have very closely related genetic cousins, Fisher rats, who when you give them the exact same pro-inflammatory trigger in the exact same dose in the exact same way, do not get autoimmune disease. So the number one, you say statistics, when I first got the data on 5 rats and 5 rats of the 2 different strains, and all of the rats of one strain died, that goes to your mortality, and and none of them on the other. You know, the statistician said, you don't need statistics here. But in those rats, and this applies to these multigenic, polygenic diseases, there were 15 genes, 20 genes on 15 different chromosomes that predisposed to susceptibility to autoimmune inflammatory disease. Not all of them were related to the central nervous system. if those rats inherit all of their susceptibility genes, there's not a whole lot that you can do with the environment to change that they are going to get. They're eventually going to get some kind of autoimmune disease. If they inherit none of them, or 2 of them, say, then the environment becomes much more important. And those environmental variables, it's really a dose relationship between genes and environment. And most of us humans are not the inbred rats. Most of us humans are like a bell curve across the population. And so for us, the environment plays a much bigger role than do genes. Not that genes don't. For example, for the dominant genes, yes, of course, it plays a big role. But if it's a multigenic, polygenic disease, which most of these diseases are, then the environment plays a big role, which is why, and that's where integrative medicine comes in, preventive medicine. What can you do to change the environment to the extent that your gene load is going to be less important in developing those diseases?
Just from my humble perspective as a GP, when patients ask me about genomics, which they do frequently because the availability of testing is prevalent, it's everywhere. It's not ready for prime time. It's in no guidelines, perhaps with the exception of high-risk breast cancer patients, is it part of what we should be doing. I think that if you're unfortunate to have a cancer, which is a fairly rare cancer, or in cancer therapies, yes, they're doing a lot of this, which is very, customized prescriptions for chemotherapy. But when it comes to what I do as a family doctor, be careful what you look at. Be very cautious about what you expose your mind to, because it could really change the way you live. My own personal philosophy in care, and this is just small cranium speaking again, run toward the light. Do your exercise, eat healthy, wear your seatbelt, don't do drugs, don't smoke. Like, it's really basic. It's all the stuff I learned in kindergarten. And that'll keep you pretty occupied, actually, if you're just doing those things. Do not run toward the darkness. Running toward the darkness is overly pursuing diagnoses, looking too hard. Because guess what? If you look, you'll find. And it could inspire your life in a way that you really don't want it to inspire your life. And incidentally, just as a last thing to say, insurance companies are actually barred from getting that information. So when you're applying for life insurance or extended health or whatever it is, and they send me a letter saying, send me all this guy's information or all this woman's information, they specifically exclude my sharing any of that genomic data. Thank goodness.
Any comment on your end, Mike? No. Question from over here? Yep.
I have a comment as well as a question. One is on that study that you showed.
There's a political aspect to some studies. The Women's Health Initiative.
We need a microphone and
that was met the criteria. It was 12,000 women on one side, 12,000 control subjects. They had, it was $750 million worth of stuff. And they found that breast cancer was increased in the estrogen-treated patients. Immediately, the study was stopped. Now, if you stop a study prematurely, it turns out that, for instance, the relationship, the study, estrogen helps the bones, it decreases colorectal cancer, it, in the long run, it's going to help patients' longevity. JAMA had 2 pages and pages of protest from statisticians and gynecologists. And then there was a Chronos study dedicated to finding how false this first study was, and they found that, it's better to give estrogen, small doses, E2, and that means millions of women were made miserable by this one study, by abrupt estrogen withdrawal. So there are perils
So many of these things don't have simple answers. But in terms of the issue of stopping a study early, there should be strict rules for that. And stopping a study early will always bias you towards finding a result, either positive or negative, that may not, in fact, be present.
Let's hold on that one. A question up on the right back. Sir? Yes, sir?
Yeah.
My right.
Comment on your, and I have a question as well, but the comment is on the article from New England Journal. I was at Mass General on the psychiatry staff at the time that came out, and just before that came out, I read an article that was reported in Science News from the University of Maryland that had done studies on drinking decaffeinated coffee. And a correlation, it was women who smoked and drank decaffeinated coffee had about 5 to 6 times an increase of what they showed in the Mass General study, which was like 3 to 1 or something like that. It was a very small outcome. Then when they studied men who drank decaffeinated coffee and were executives, apparently wearing suits was a correlation, that they had them dry cleaned, and it was associated with one of the chemicals that had been banned from dry cleaning that was used to decaffeinate coffee in Sanka. And soon thereafter, Sanka quietly said they were water processed, as Nescafe had been all the time. The other background to that is, I wonder why they did it, but John Knowles, who had been the previous general director, had gone to Rockefeller Institute to take that over, and he had then developed cancer of the pancreas and died at the age of 51 at the Mass General. And I wondered if it wasn't his people seeing him drink a lot of coffee, but maybe he drank decaffeinated coffee. It's hard to say. The other comment on that was the senior author listed George Nardi, who was a surgeon who took out my gallbladder as well as Henry Kissinger's. Well, my question, though, is about the health records. I have been doing a lot of frontline treatment. I'm a psychiatrist and been working in different places and contracting in California after I left working different steady jobs. And the care out there is tremendously difficult once you get outside of major cities. And the major problem in the healthcare record is the EMR, that they ask for so much data that is of useless to clinical work. And I'm interested that you said that they read the written notes first, because I had a colleague who went to one clinic and they gave him his caseload, then he increased it to full caseload, and he spent all of his time having to punch data into the computer. He could not, and this isn't psychiatry where it's anathema. I realize in surgery and medicine it's been going on more, but you couldn't do your work if you talked to the patient. You had to be constantly typing into the computer as you talk to the patient. Now my question is, it's out of control. Now some of my colleagues who aren't doing direct care, Michael, he hasn't had to answer the computer enemy. But who's going to get control of these people? It's administrators who know nothing about clinical care and just want more data. The computers created a devil because, oh, look, we can ask for more, and we can ask for more, and we can ask for more. My colleague left because they said, why are you leaving? He said, I'm a psychiatrist, not a computer data input clerk. Who's going to get them?
In the interest of time, quick answers, quick responses?
Very quick responses. You covered a lot of ground. Yes, burnout is directly proportionate to the number of keystrokes a doctor makes. That's concerning. Second concern, digital checklists. It's kind of a love and a hate relationship. They force doctors to potentially lie about what they've seen. I'm worried about that. I'm worried about what implications that has toward research, especially with systems like Epic that are based on billing. So pop-up charts come up and doctors have to check boxes in order to justify billings for large organizations. So these are major problems. Major problem, patient is being lost because there is no narrative. And so ideas that have come around that, I'm trying to get an article published on this actually. It'll probably be refused, but who knows, where patients actually write their narrative first. This is somewhat evidence-based. I'm sure it does not meet your criteria because there's no money on it, but that said, you write your main complaint, and that becomes part of the record. And it also aligns what the doctor does to the patient's complaint. So with tech, what we're going to see eventually is a loss of typing, that there's going to be some sort of a recording system going on between doctor and patient, and an AI automatically arranges that information into a way which is accessible to good quality research, while at the same time frees the doctor to face the patient more than 50% of the time. And understand, with keystrokes now, we are looking at our computer screens 52% of the time. That's not acceptable. So we will get better, but like everything, it takes time for tech to catch up. We have to go backwards in order to go forwards, and that'll eventually happen.
Any parting comments from others? Good. Terrific, because I want to be on time. I have 3 tasks to do. One is to remind everyone, please, on your way out, hand in the survey. 2, class parties tonight, just to remind you, 69, 84, 89, 2004 at the Omni. And I don't know how the guys in the class of 79 got Cafe Ferrera, but hey, that's a whole different league, but that's where they are. So 1. 2, second comment. I started this morning with a comment quoting Vinod Khosla about big data and how data is going to change, his views on how data is going to change the way we move from the practice of medicine to the science of medicine. And I found this all fascinating when this has evolved. If you remember, Dr. Dave talked about taking the I am away from impossible. And he really talked about how technology has changed things, how it's going to continue to change things, and he implored leaders, us as leaders, to accept that change. The talks today, Iris talked about imploring us to advocate for increased sharing of information with patients. We had Esther talk about what data does in the work environment, how that makes people healthier, and the advances just by knowing. We had Michael talk about empowerment of education and getting and making a difference in impoverished countries, and how we can actually as leaders do that. And then we had Joel talk, and interestingly, skeptically about data, which now, it'd be really interesting as all of us watch this big data evolution, how we do monitor and accept and use that data and treat it as fact or fiction. It'll be very, very interesting. But I have two very interesting anecdotes. One is I sit on the advisory committee of the Ivey Center for Health Innovation to do with the University of Western Ontario. And we sit with the dean and with both the dean of the business school and the dean of medicine. And we talk regularly about doctors being the gatekeeper to technology and the slowest actual adopters, and how that's a problem and how it needs to start with the leaders and right in the early classroom about allowing for technology to come into our world for its use across our patients because of the improvement it can make to lives like we've seen in your study, Esther. And just data drove that. Second thing is I had a dinner last week, actually, with the Minister of Finance for the province of Ontario. And there's a small group of us, and his opening comments were fascinating about healthcare being the #1 line item in the government's budget, but how they in fact only control 9% of the dollars. That 91% of that line item goes to the hospital CEOs, the doctors, our clinics, and how they were asking the group in the room as one of the questions, how can we start to have any levers to allow and encourage doctors and the leaders of the healthcare community to move technology forward? And because some of these technologies are cost savings, and we're not aligned around cost savings necessarily, even though they may improve health. Very interesting to hear how this data is coming forward, what governments are saying, and ultimately where the future of medicine is going. So with that, I'd like to thank you for your time and attention. I'd really like to thank our 4 speakers, and Dr. Dave, of course, who had to leave. And I have just a few gifts to give out on behalf of the Faculty of Medicine. And would encourage an applause.